Hello friends, welcome to this tutorial series on network analysis made simple. In this tutorial, we shall solve the questions from series resonance circuits of EC, EEE and GATE examinations. Friends, first we shall solve question 1, which is easy and straightforward. It states a series RLC circuit has R is equal to 4 ohm, L is equal to 1 millihenries and C is equal to 10 microfarads. We are required to calculate resonant frequency, Q factor, bandwidth and half power frequencies. Friends, by analyzing the given statement of the problem, we find that all the circuit element values are given. So, straight away we can use omega naught is equal to 1 divided by root LC. By substituting the values of L and C and solving, we get omega naught is equal to 10 to the power of 4 radians per second. And also we know f naught is equal to omega naught by 2 pi. By substituting the values of omega naught and solving, we get f naught is equal to 1.59 kilohertz. Next, to find q, we know q is equal to omega naught L by R. By substituting the values of omega naught, L and R and solving, we get Q is equal to 2.5. Further, we know bandwidth is equal to omega naught by Q. By substituting the values and solving, we get bandwidth is equal to 4000 radians per second. And also bandwidth is equal to f naught by Q. By substituting the values and solving, we get bandwidth in hertz is equal to 636 hertz. Next, to find the half power frequencies, we know omega 2 is equal to r by 2l plus square root of r by 2l whole square plus 1 by LC radians per second. By substituting the values and solving, we get omega 2 is equal to 12,198 radians per second. And F2 is equal to omega 2 divided by 2 pi. By substituting the values, we get F2 is equal to 1941 hertz. Further, we know bandwidth is equal to omega 2 minus omega 1. We have already calculated omega 2. Therefore, we get omega 1 is equal to omega 2 minus bandwidth. By substituting the values and solving, we get omega 1 is equal to 8198 radians per second. Finally, F1 is equal to omega 1 divided by 2 pi. By substituting the values, we get F1 is equal to 1305 hertz. Hope it is very simple. Friends, next we shall solve another interesting problem which needs a little bit of thinking. By analyzing the problem statement, we find that the circuit is operating at a different frequency other than the resonant frequency, and we are required to find that operating frequency in radians per second. The data given is the current leads the supply voltage. The magnitude of the current at that operating voltage is half of the current at resonance, and RLC values are given as R is equal to 1 ohm, L is equal to 1 Henry and C is equal to 1 farad. From the statement 2, we can write I is equal to I naught by 2, But we know I naught is equal to V divided by R. Hence, I is equal to V divided by 2R. Also, we know I is equal to V divided by Z. So, we get I is equal to V divided by square root of R square plus 1 upon omega C minus omega L whole square. Note, current leads the supply voltage, meaning XC is greater than XL. By equating the right hand sides of the two equations, we get phi divided by 2r is equal to phi divided by square root of r square plus 1 upon omega c minus omega l whole square. Friends, the equation obtained is reproduced here, from which we get 2r is equal to square root of r square plus 1 upon omega c minus omega l whole square. By substituting the values of r is equal to 1 ohm, l is equal to 1 Henry and c is equal to 1 farad, we get 2 into 1 is equal to square root of 1 square plus 1 divided by omega into 1 minus omega into 1 whole square. By squaring it on both sides and solving, we get a quadratic equation in omega as omega square plus root 3 omega minus 1 is equal to 0. By solving for omega, we get omega is equal to 0.457 radians per second. Is it not interesting, friends? Friends, now we are going to solve yet another interesting problem. Note the data given. Phi R is equal to 80 volts, Phi L is equal to 40 volts, and supply voltage Vs is equal to 100 volts. We are required to find the voltage across C. We don't know whether XL is greater than XC or XC is greater than XL. Now, let us assume that XC is greater than XL. Then, current will lead the supply voltage as shown in the phasor diagram. From the phasor diagram, we get phi s squared is equal to phi r square plus phi c minus phi l whole square. By substituting the values and solving, we get phi c is equal to 100 volts. If you assume XL greater than XC and solve, you get phi c is equal to minus 20 volts, which is not correct since phi c cannot be negative. Friends, finally, we shall solve question 4. Observe the given network. We are required to find the resonant frequency. Note that in the given circuit, the supply voltage is not given and it is also not required to find the resonant frequency. But see that the inductances are magnetically coupled and also note that they are differentially coupled. Hence, L equivalent is equal to L1 plus L2 minus 2M. By substituting the values, we get L equivalent is equal to 2 henries. But we know omega naught is equal to 1 divided by square root of L equivalent into C. By substituting the values, we get omega naught is equal to half radians per second. And F naught is equal to omega naught by 2 pi. By substituting the values and solving, we get F naught is equal to 1 divided by 4 pi hertz. Friends, during this tutorial, we solved few interesting problems. We shall meet during the next tutorial and solve some more typical problems. Thank you for watching.